So to start with the next lecture, and that is very important, and it is in continuation with the plasmid isolation. When you have isolated your plasmid, now you have to check the concentration, the purity, and some other contaminants while you are working with your plasmid isolations. So what are the 4 things which we have to be take care? As I have already explained in the previous lecture, that there are 4 things which we have to do immediately after the plasmid isolation. The first one is you have to check the concentration of your plasmid. And the second thing is you have to see the 260 by 280 ratio. Third thing, you have to check 260 by 230 ratio. And the fourth one is you have to run agarose gel to check the quality of the plasmid which is isolated. So what is concentration? Concentration means how much nanograms. Suppose if you are isolated and eluted your plasmid in 40 microliter. So how much concentration of plasmid is there? So you have to see that suppose it is 76 nanogram per microliter. That is the concentration of your plasmid. Means if you take 1 microliter of eluted plasmid, then it has 76 nanogram. Then you have to see the 260 by 280 ratio, that it should be between 1.8 to 1.9. The ratio should be between 1.8 to 1.9. So you have to measure, while you are measuring your concentration, you have to see the 260 by 280 ratio also. Then you have to see the ratio of 260 by 230. Why we have to see 260 by 280? Because all your nucleic acid, it will absorb at 260, and all the other your protein molecule, they will absorb the various amino acids in the protein molecule, it will absorb at 280. So you will get a curve at 260 and 280. Then it will calculate your ratio, that it should lie between 1.8 to 1.9, and if it is below 1.8, that means your plasmid is contaminated by your proteins. And if it is more than that, then that means it has RNA contamination also, it has many other contaminants also. So you have to see this. Then you have to check the 260 by 230 ratio. 260 because 260 all the nucleic acid it will absorb at 260, and if 230 ratio, it will show 230 is, if it shows absorbance at 230, that means some organic molecule like phenol or alcohol is present, and those organic molecule it is contributing to your concentration, and it should be around 1.8. And if it is less than 1.8, that means your plasmid has some amount of alcohol or some amount of phenol or some amount of other organic solvents. So you have to see this. Then you have to check the agarose gel. And why we have to run the agarose gel? Because we want to see the purity of your plasmid. Purity of plasmid means sometime if your plasmid is degraded and it is or it is not in intact form, then it will show the concentration, it will show the purity, means it will show the ratio 260 by 280 ratio, it will show okay, 260 by 230 ratio is also okay, but you have to see the integrity of the molecules. So for that, for the purpose of agarose gel, how it will look when you run? So what you have to do, you have to prepare 0.8% agarose gel. 0.8% agarose gel you have to prepare, and you have to load 1 to 2 microliter of your plasmid. You have to load 1 to 2 microliter of plasmid. How it will look? Suppose this is your agarose gel image, and these are your wells. You have loaded in those wells. So what you will see? You will see bands like this, very thick band here, and very faint band here, very faint or light band you can see. So what are these 4 bands? these are different conformations of the plasmid, because whenever you are doing alkaline lysis method or you are doing some other method, the protein or the plasmid molecules, they will have different conformation, you can say, or they will fold or linear or maybe neck circular. So this lower band we'll discuss later. This is dark band is your supercoiled form. Supercoiled form. And this is the actual form, or this plasmid amount is actually we need for our purpose. Then you have your linear plasmid. Then you will have your nicked circular plasmid. Nicked circular plasmid. So the plasmid molecules, some of the molecules, they are nicked, means they have like this cuts, right? And linear is your this form. Supercoiled is your highly packed structure, and this lower band is, it is single stranded plasmid molecules. Plasmid molecules, you can say these are your circular, closed circular plasmid molecules. Plasmid molecules. And these molecules, because these are single stranded and it is resistant to digestion also. So which form is important? You need this supercoiled form, which in which the plasmid is tightly coiled and it is packed, and this form is of further your importance. So you can isolate this particular by gel cutting or gel elution method, or you can see which, if it is in sufficient amount, then it will solve your purpose. So these are the this is the method in which we can check the integrity of your eluted plasmid. Now one thing here I want to discuss is very important. This is your uncut plasmid, right? When you digest your plasmid, so you will get a single band here. Closed, it is closed, or it is very close to your linear form. So it is digested, your digested plasmid. Now if you have ligated, suppose this is your 3 kV, this is also 3 kV, and you have added one insert of 1 kV. So how your plasmid will look? So it will look, this is supercoiled, so it will go little bit, it will go little bit up. The linear will go more, 1 kV up, and like that. So there is hairline difference. There is hairline difference in your plasmid. So suppose this is your supercoiled form, so it will go here. It will go slightly up because of shifting of this position of the band, shifting of the band towards the gel, towards the well side. It will show that yes, 1 kV insert is ligated to the plasmid. So if you run the gel sufficiently, अगर आप इस जेल को पूरा नीचे तक अच्छे से if you run, then you can see a clear difference in uncut versus cut. Suppose this is your supercoiled form, this is your linear form, and this is your nicked circular. So आपका with insert में कैसा दिखेगा? How it will look? So it will go like this up, this will go slightly up, and this will go like this. So there is shifting in the bands. There is shifting in the bands. Shifting of bands towards your well side. So like that you can see, yes, your plasmid has insert. So this is one clue after purification. After like eluting your plasmid, immediately when you are checking the purity or the integrity of your plasmid, that time you can see even you can check or see, you can differentiate nicely the ligation of insert in the plasmid because of shifting in the bands. But if shifting is not there and it is, the bands are exactly at the same position of the linear and this, like this, that means the ligation is not successful and this plasmid is without any insert. One more thing, if your insert is very small, like 100 base pair or 200 base pair or 300 base pair, even then you cannot see the difference between ligated versus unligated or uncut versus your recombinant plasmid. So for that you have to confirm by your PCR method. So this is the way or the method by which we can check the plasmid purity, plasmid integrity, plasmid concentration by 4 different ways: by measuring the concentration, by nanodrop, and to see the 260 by 280 ratio. You have to see 260 by 30 ratio. Then you have to check the integrity of plasmid by running on the 0.8% agarose check. So these are all the method that we have to see after plasmid purification. Once your plasmid is fine, all the condition it will pass, then you have to confirm your ligation by simply by performing a PCR, insert specific PCR or vector specific PCR, that we have discussed in the previous lecture. So thank you. So in next lecture we'll go with other technique like ELISA. But before ELISA, I want to discuss a very important thing, that is sample collection and sample collection vials. Whenever you are working with your plasmid, your blood sample, that time how to prepare those samples, that we'll discuss in the next lecture. So thank you.